some kind of gravity waves from them, because basically when this big explosion happens, that whole space-time curvature, the gravitational waves that you would expect, it loses gravitational energy, and it puts that out. And if we have a sensitive enough instrument on Earth, or even a satellite of Earth, right now we just have Earth ones, we don't have the satellite ones put out yet for gravitational waves, but being able to see that, that's another part of the picture. Same thing for the particles. These environments potentially, theoretically, hypothetically do a bunch of stuff with the particles in the environment as well, but we won't really be able to confirm that until we can measure as well those particles. And we would have to kind of do that, like sort of pointed in the sky. Like if the gamma ray burst is happening here, we want to be looking here, right? And we want to make sure that the gamma rays came from there, and the other particle came from there, and the gravitational waves came from there. We can't be looking over here, So this type of like what we call more more directional and point source or source search. Basically, there's the types of search of particles from the whole sky, or from whatever sky that you can see, right? Like for example, the South Pole Station, IceCube, is a neutrino observatory in the South Pole. At the South Pole, so the biggest billion-dollar neutrino observatory with the most number of high energy neutrinos measured is IceCube. They're still operating at the South Pole Station in Antarctica. So they look at the southern sky. Of course, they can see neutrinos that would go all the way through the Earth from the northern sky as well. But basically, there are searches for neutrinos, for example, that kind of look at, they don't really care about the direction that the neutrino is coming from. It's sort of like an all sky search, even though all sky might be a little bit of a generalization. And then there are searches that are more of a source search, where you care about the direction. So something like gamma ray burst, if you were to prove out that your neutrino definitely came from a gamma ray burst, then you would need that multi-pronged approach. You would definitely at least want to be able to say that you definitely had the gamma ray coming, like you saw the neutrino at the same time when the gamma rays were coming from that particular source, and during that particular time during which the gamma ray burst happened. Because remember, with gamma ray bursts, the nice thing is that you would also know in time when it happened. So that kind of helps as well, sort of. It's amazing how in-depth physics is, simply breathtaking, how it takes you to such unbelievable beauty within our existence and everything that surrounds us. Yes. Yeah, physics is yes, I love that about physics. The physical sciences really explain our existence in more depth. The most widely, so now we will talk about GRB theory. Okay, so even though we did not measure gamma ray bursts and all the different things one could potentially measure from gamma ray bursts until more recently, there are plenty of theories about gamma ray bursts, because we started to see them. Of course, we discovered them in 1967, like we mentioned earlier. And because we discovered them and we've had them around for, well, a long time, at this point, 60 plus years or so, or is it 60 years? Someone do the math. How long ago was 1967? We've had gamma ray bursts for that long, and they somehow are still a bit of a mystery. And we will see why. It can be difficult to learn about them, so we will see. Actually, give me 1 second. Let me check on my... Oh, you know what? It's fine. It's all good. Whatever. Okay, we will talk about gamma ray burst. It's amazing. Oh yeah, I read that comment. Gamma ray burst theory in the early days. So this is gamma ray burst theory in the early days. The most widely accepted theory for gamma ray bursts endorses a relativistic fireball. So we'll talk about the fireball, but basically a gamma ray burst is a relativistic environment. Things happen very fast, things happen with a lot of energy. So it's not, you can't do